All right. All right. Maybe I should give some brownie points for those that show up here. Sorry? Are the undergrads in person? Yes. The Tuesdays. Yeah, both undergrads are in person. Yeah. All right. Let's get started. Let's see. Yeah. So we're well into the second half of the semester, right? And right as the first half focused mostly on implementing the front end of a web application, and we are using a client-server architecture, right? We focus mostly on the first half in the building a client application, right, which is a front end in a part of a multi-tiered application, right? This front end being the first tier, right, that mostly just interacts with the user, displays feedback, right, and graphically represents some data structure so that the user can manipulate it, add, remove, update. But we ran into some limitation with just the user interface. We don't have a place to permanently store any of that changes, right? As the application changes from one state to the other, we have no permanent place to store that, right? So, and that's because, right, the browser has limits what the programs that run on a browser can do, right? One of the limitations is that a program running on a browser cannot access the file system, right? And that was done early on when JavaScript came out, right, as a means to convince folks to allow executable scripts, right, to download into your machine, right, and execute locally on your browser, right? So one of the limitations that everyone agreed on, it says, okay, well, we're not gonna let JavaScript access the file system, right? Browsers will not allow that, right? Other limitations is that we can't just willy-nilly talk to anyone on the network, right? We need to adhere to some security policies. Okay, so to escape these limitations, multi-tiered applications, what they do is that they have a secondary process that is not running on the browser, right? That is running in a normal process that can access the file system, access the database, have unfettered access to the network, right? And then we need to integrate these two parts, right? And the way we're going to integrate it is to use HTTP connections in between these two processes, and that's where we are, right? We're learning, starting the last lecture, we discussed how to implement these servers, right? Using Node.js and Express library, right? That allows us to start up a Node server that can listen at a particular port, a particular IP address, right? And we were practicing, how is it that we could create endpoints, integration endpoints that we can send URL connections to the server, and how the server could respond, how could it calculate certain things, in particular, certain data structures like assignments and courses and whatnot, right? We discussed the path, the request objects, the response objects, right? And the various formats of encoding data, either in the path or query strings and things like that, right? So we're exploring, the basics of creating a server, creating routes that would allow us to integrate with it. So let's continue that. Let's continue that discussion. In particular, let's discuss how is it can we now integrate these endpoints, right, with a user interface, right? That's the intent, to have the first tier and the middle tier talk to one another, right, through this RESTful Web API, right? And we'll talk about REST in a minute. So we have these two tiers, right? The first tier, the front end, the middle tier, and the middle tier kind of suggests that there's another tier, right? That the middle tier is kind of in the middle of these two tiers, right? The last tier that we're going to be discussing next week, we're going to introduce a database, right? Because right now, what we're doing is that we're moving the data away from the user interface. We're going to move that over to the server. The server is going to be responsible for maintaining the state, the application state, in particular because it can save it, right? It can, it has a broader context as opposed to a browser only has a context of that particular page that you're on, and the server is has more capabilities to be able to store things in the file, database, and whatnot. But up to this point, and even today, we're going to store data still in the memory of the server, right? So it's not truly permanent storage, right? As long as the server is running, it can maintain the state of the application. We can add new courses, delete courses, update courses within the memory of the server. But once the server reboots, that's gone, right? And it would reset whatever initial variables it had. To make it truly permanent storage, it would actually have to save those changes to the file, right, to a file system, which we're not doing, right? But we could, right? And that's pretty trivial. It's just just a few lines of code to load and save to the file. So instead, we're going to wait until we get to databases next week, right? And instead, we're going to just save directly to a database, right? We're going to skip over saving to the file system, even though if you want to explore that, it's a really trivial API in Node.js, right, to read and write to the file system, not unlike any other library in other languages, other infrastructure. So instead, we're going to wait up, and next week we'll integrate it with the database. Yes. Well, the server will be running from the console, right, and it will have access to the file system that it's running on. Right, and so it can use the Node.js has libraries, right, that can read and write from the file system, right? And since it's running outside of a browser, it doesn't have those restrictions, right? So we could certainly do that. We could certainly, as we're adding or removing things to make it really permanent, right? It could save those changes to a JSON file, right? And next time it reboots, it could reread those files, right? And those data structures and reinstantiate all that data in memory, right? But a better solution is what we're going to do next week, right? We're going to introduce a database next week. So instead of reading and writing to the file system, you go through a database, which the database will read and write to the file system, right? But it'll be a higher API. It'll be a higher level data structures, right? So databases is just it's just an abstraction, right? That allows us to think of data in terms of tables and foreign keys and primary keys, that things are related to one another. Those are all abstractions, obviously. None of that actually exists, right? There's just a convenient way of thinking of how data is structured, right? In the end, everything gets written to the file system in just binary, right? And then it gets reconstituted in this abstraction layer. So that abstraction layer we're going to be using next week, and we're going to be using the non-relational database Mongo. Okay, that's more later. So let's talk about that. Let's talk about integrating the front end with the server, right? So we'll cover that the first half of the of today's lecture. The second part of this lecture, I'd like to discuss multi-user, support, right, from our server. Right? Up to this point, the application that we've been building has been really for one person. Right? It's just us, right, interacting with the user interface. We have access to all the courses, right, all the modules within those courses, all the assignments. There hasn't been really any consideration of having multiple users at the same time, right? Just because we've had just one front end. But because we're going to move a lot of the data processing, right, all that work is going to now be the responsibility of a server, right? Now we're going to have the possibility that we're not just going to have one front end, right, accessing the server. We can have multiple instances of the front end, right, even spread out over the world, right? All of them accessing the same central server, right? So now comes the question. Well, how would you support that, right? How that would everybody just see the same thing? Would everybody be editing always the same common data set, right? Or could we want to maybe distinguish between different users, maybe have them create accounts and register, log in, right? And have their own private space, right? Their own private profile. And then associate these data structures for a specific identity. So that if I log in as Alice, I would see maybe the courses that I created as Alice, right? But if you log in as Bob, right, you would see the courses that Bob created, right? And we would not perhaps have access to each other's, right? Unless the application would allow some kind of cooperation where we might be co-faculty, right, for a particular course, co-instructors. So let's discuss that, and we'll introduce that a little later in the second half of the of today's lecture, and all in preparation for you being able to implement and support this kind of feature, right, for your own projects, right? So one of the requirements on whatever project you're working on is to support multiple users logged in simultaneously, each one being able to maintain their own identity, right, and all the data that is associated to that identity. Okay, all right. So we'll introduce that in the second half of the lecture today. The project, right? You should. We did discuss the two options for the project, right? The generic kind of like social network around a topic of choice, right, where folks can collaborate around a particular data set, right, of your choice. And the other one was for extending the Canvas application, where I'm suggesting that you could use the quizzes as a topic of choice, right, where you extend the capability of the current Canvas assignment, where faculty could log in, create quizzes, right, for a particular course with different questions. Yes. So those are two options. Now, if you have other ideas, right, of other ways that you might want to consider extending Canvas, right? Maybe you might want to integrate it with YouTube, or want to integrate it with other libraries, other APIs. That come see me and we can negotiate. Yes. Yeah, for the quizzes, there's no requirement for the for an API. Those are if you have something better, obviously, then it will absolutely take that. But if you have questions, specific questions, maybe we can take a look at it. That where you want to deviate, and we could certainly say, oh, that's much better, right? And we'll take that instead. Yes.
The social networking one, we look through the requirements and we don't really see anything that's like explicitly social networking in the way of like adding friends, messaging friends, sending content.
Yeah, what I meant by social is that you have multiple users sharing somehow in a common data set, right? Whatever that is, and that there should be some kind of relationships between users, whether I'm your manager or I'm a faculty and a student. So we're socializing around education, but not social networking as in Facebook or anything like that.
I'll post a more detailed question.
Yeah. Yeah, sure. So yeah, no, if you have any relationships between users and domain objects and other domain objects, right? And the different types of users, then sure, that works. Okay. Let's all right, so let's take a look at where we left off. Let's see. Right, so we took a look. We were practicing last lecture. We were practicing on implementing a trivial HTTP server, right? And we were playing around with creating routes that where we can send data to a server, either embedded in the path, right, or embedded in a query, okay, and then generating a response, okay, and we also looked at creating routes that would allow us to interact with some data structure, such as an array of courses, right? That would allow us to retrieve all the courses, or retrieve a particular course, right? Or find the sections for a course, right? And so these and we saw that we can interact with the server by providing or sending these requests, right, out to the server, and the server would compute, right, and calculate these responses back to the as a response, right, to the request. Yes, right, and we also discussed that collectively, right, these URLs, right, being able to retrieve all the courses, or retrieve a particular course, right, or by sections and whatnot, together collectively, they constitute an application programming interface, right, an API. Right? And what we mean by an API is that typically an API consists of some object or set of objects, right, that have a certain set of functions that are available within those objects. Yes, right, and each one of those objects has a particular signature, right, that has a specific name, the parameters that it expects, right, in a specific order, the data structures that it expects, the different types that it expects, right. Collectively, right, these functions, these parameters, the data types, right, constitute an API, right, a means by which one program can use another piece of program, one piece of software using another piece of software, right, through some interface that is well documented. These are all the functions, these are all the data types, these are all the parameters that you send me, and these are the things I am going to respond, right, and it's well documented as an API, right, so that two pieces of software can use each other. Well, we have the same thing here. We have a piece of software that was implemented as a user interface with React.js, right, that wants to render some data types, yes, some data structure. And here we have another piece of software, right, that can manipulate a data set, right? In this case, courses and sections and assignments and things like that. Yes, and they need to talk to one another, right? So we need an interface. Okay, and the interface is these set of URLs, right? And these URLs have a specific set of conventions, the names that we give them, right? How we organize them, right? That we are following what we call the RESTful Web APIs, right? That for retrieving data, these are gets, that they're all prepended with API, right? That the naming convention for these paths contain all nouns or primary keys. So and then they're expecting things either encoded as a path or encoded as a query, right? So the collection of all this organization, right, of web URLs and the formats that it's expecting, what it's responding as an array of things, of objects, right? So it constitutes an interface, yes, and the goal of this interface is for two pieces of software, to programmatically interact with one another. So in that sense, it is an API, right? It's an application programming interface. It's an interface for programs to talk to one another for building an application, an API. But it's a web API, right? It's an API that is accessible through the web, right? So we refer to them as web APIs, and they're following a specific naming convention, right? That we said the RESTful Web APIs. Okay. So let's expand on this. In particular, let's explore now how can we integrate these APIs, right, with a user interface. Right now, the only way that we are interacting with the server is me typing, right, these URLs at the at the URL input field, right? But more interesting, we would like to be able to come to the come here in the user interface, and now instead of rendering in the user interface this hard-coded JSON objects, right, that live in the file system in a browser, we would like to be able to instead get all this data from a server. Okay, so we're going to move all the data that we had in the front end. We're going to rip that out. We're going to move it over to the server. Eventually, it's not even going to be in the server, right? It's going to be in the database, right? But we don't have a database yet, right? So just like we faked the database in the front end, we're going to fake the database on the server, okay? And we're going to focus on the integration portion, right, of the user interface and the server. And we'll eventually next week, we'll move the data finally where it really belongs in the database, right? But we don't have a database just quite yet, right? So we'll look at that next week. All right. Okay, so let's do that, and we'll use the Canvas as a use case, right, of implementing this APIs, implementing the interface between the two, right, and see how the communication works. All right. Okay. All right. So let's take a look at that. So I had provided to you in the assignment, I had provided with files that contain the data set that you can use as a sample, right? So let me provide that to you. Let's take a look at that, which is mostly what you already have in the front end, right? Maybe slightly a few things different, but it's mostly the same thing. In particular, right, they still have the IDs, they still have names, right? I think those are the only things that you really need. They're the same from prior assignments. So you should be okay, right? Everything that you've built so far in the front end should be forward compatible with what I'm giving you here. So I'm going to save this to our local file system. And so let's NU 2014 Spring, and we are here. Here's Node. And so here, let's create a database, right? So database. And I'm going to save this as my courses. All right. Let's do the same thing with modules. And I'll leave everything else to you. You can implement the rest. So I'll save this as modules. There we go. Let's save that. And let's confirm that they are in our file system. There they are, the two files. Okay. Okay, so one of the things that you'll notice is that these are not JSON files. They are JavaScript files, okay? But they contain the same data. Notice that these are arrays of objects. But the only difference is that they're not JSON files. They are JavaScript files. They're declaring the data structure in the JavaScript, but they're exporting it. They're exporting so that we can import them from other file systems. Okay, right? The only reason why these are not JSON files is because I was lazy, and by default, Node.js doesn't know how to parse JSON files, doesn't know how to import JSON files, and importing JavaScript files is for free. Right? I need to install a few other libraries and configure a few other things. That was just me being lazy. So here we're going to create the index.js that is going to import both data types. So we do import courses from courses.js. That's another inconvenience. You have to explicitly say the extension. Again, there will be more configurations to the Node project for that it would automatically parse this. Import also modules, and we're going to export and put together here an object that contains both the courses and modules. Everybody good? Right? So just basically, this is just one big object that contains two properties, and the properties are those values, which are just those arrays, right? So somebody who might want to look at this would import this file, right? And then they could do db.courses or db.modules. Everybody good? Now, as you might know already, if the name of the property and the name of the variable are the same, right? JavaScript provides the syntactic sugar that you don't have to provide the name of the property of the value, right? You can collapse that into just the name of the property. Yes. All right. So that's just a syntactic convenience, right? So yeah. So we have that, and we had already explored courses, to as an endpoint for interacting with courses. So I'm going to break that a little bit. I want to revisit that, so I'm not going to import that for now. So leave that for now, okay? And instead, I'm going to maybe rename this, as an older version. I'm going to create a directory because we're going to do a lot of work with courses, right? So I'm going to create a whole directory, courses, and then in there, we're going to create routes.js. And let's revisit the routes here, okay? Right, so here, we're going to implement that API. We're going to implement an API that would allow us to interact with that courses database, right? So let's import the database from database / index.js. So we have the courses there. So we're going to export, and these are going to be the courses routes. And so the architecture of these routes has a very peculiar and very typical pattern, right? And typically any data type or any data set that you're going to interact with typically has certain operations that are very common, right? That you'll see them over and over, right? And these operations typically fall under the moniker of CRUD, right? We want any data type, any piece of information, you'll want to be able to create an instance of these objects, right? You're going to be able to read or retrieve, right? These instances, you want to be able to update them, right? Or you want to delete them, right? So those are the the 4 big buckets of operations of any data type that you're going to interact with. Yes, right? So for instance, we might want to be able to retrieve all courses, right? Request response. Okay. You want to be able to retrieve a particular course by their ID, right? You want to be able to create a particular course. Maybe you want to be able to update a course, or you maybe want to delete a course, right? So those are the most common types of operations. Then we can think of a few more, definitely plenty more, right? But in general, right, these are the most common things that you're going to be implementing over and over. You'll see that there's a pattern here, right? It's so common that after you've written a few of these, you'll ask yourself, could I generalize this? Right? Could I create a general solution to this so I don't have to do this ever again? Okay. Very much like an ORM in databases. I don't know if you've looked at ORMs, right? That once you implement one data access object implementation that does all the CRUD operations with a database, you'll realize that they're all the same, right? All the inserts, all the updates, or all the select statements, they all look the same, right? The only difference is the schema, right? The schema and the data types and the fields. Those are the things that change. So same thing here, right? Once you've implemented a few of these, you'll find a pattern, right? It's always the same, right? The only thing that changes is the name of the thing, right? And what are the fields and the relationships between them. So yeah. So we're going to implement a few of these first, right? Let's implement the easier one first, right? And so let's implement these retrieve all courses or retrieve course by ID. So we'll do. So here's the first one, right? So this one is a mapping that says, if the URL comes in with a GET request, right, and the path looks like this, /courses is going to retrieve all the courses, right? And now the design or the choices of whether this is a get, a post, a put, a delete, right, and what that URL looks like, right, and has its choices, has its design choices, right, and so we're going to be using the design choices of RESTful Web APIs, right? REST stands for Referential State Transfer, and it's a set of best practices, right, that have evolved over time in industry, that have collectively chosen certain conventions, right, that have worked well in the past, right, like a design pattern, right. So one of the design patterns is that if you are retrieving data from a centralized server, because you're retrieving, then we should use the HTTP GET request. That's pretty reasonable, right? GET, sounds very much like you're reading or you're retrieving. Yes. Another convention is that you should use plural nouns, right, to describe the resource or the data that you are retrieving. In our cases, we are retrieving courses, so a good name for this is courses, right, and it's plural. Another convention is that these URLs, so that's a URL right there, right? But this is also a URL. Now, these URLs are distinguish themselves. They're different, right? Even though they are HTTP / port number, IP address, and some path, right? They both share that same that same general structure. These URLs are meant for rendering something for a user, for a human user to consume this content. Yes. Notice that the response comes back with graphical representations and colors and white spaces, right, and images, right. So this is clearly meant for human consumption, right? Whereas this is not. Right? This is data, okay, that doesn't care how it's rendered, right? It only cares how it's formatted, right, with fields and data types and whatnot, as arrays, objects, and whatnot, right? So this is clearly not meant for human consumption. This is meant as an integration point between two processes, that one process wants to consume this data, right, for then later converting it into some graphical representation. Yes, right. So to make it clear, right, to make it very, very clear that this URL is not for human consumption, one of the conventions is to prepend these URLs with a key or a token that we can all agree that it means that this data is only for integrating two processes, right, that want to exchange data. Make sense? A very common token is API. Other very common ones are data or REST, right? I'll choose API. API is very common, right? Everybody good? Okay. So another convention is that if you don't provide that, this URL should contain the token and then only nouns and primary keys, right? Nouns and primary keys. Yes, right now we have a noun. Now, if we don't have a primary key, the interpretation is that you mean to retrieve all the instances of that resource. Like, for instance, /courses, presumably, since you're not providing a primary key, the interpretation is that you want all instances of those courses. Yes? So let's implement that. So here's retrieval courses. It would respond with sending back the database.courses, db.courses. As simple as that, right? Well, probably not as simple as that, right? We might need to be a little more nuanced here, right? Because what if there's thousands of courses, right? This would literally retrieve and come back with all the courses in the database, and it could be thousands of courses, right? It could be megabytes, gigabytes of data, right? That you're asking the server to send back, and that probably is not realistic. Okay, so typically there would be some additional mechanism that would allow you to paginate this data, right? Give me maybe 10 at a time, right, or 20 at a time, and I can ask for more, right, and I can go to the next 20, next 20, and so on and so forth, right? So, but I'm not going to get into that, right? But in realistic terms, you would need to provide some pagination mechanism. You will not literally respond with the entire data set, okay? So yeah, so let's try that back here, and let's import the courses routes and provide the courses route with app. And so that should work exactly the way we had it a moment ago. There it is. So we have all the courses available. Okay, very good. So you have it. You have now a data set that is accessible through this endpoint, and we surely need to implement all the other ones. Okay, we'll implement all the other ones as we go. But I did want to focus on how do we integrate this with the user interface. So let's go to the user interface, right? Let's try and integrate with this endpoint, right, and see if we can catch this data. What we want to be able to do, right, from the front end, this data right now, right? If we look up the dashboard implementation, right? Here's the dashboard implementation. Right now, the dashboard is rendering the data from this courses.json, right? This JSON file, right? We want to stop that, right? Because we are limited, right? We can't modify that JSON file. It's in the file system, but we can't modify it, right? So we don't want to rely on this JSON file anymore, right? And that obviously breaks my front end. Okay, so somehow I want to be able to come and fetch the data here from the server. I want to programmatically, right, generate this request. Right? I want to programmatically go get the data from the server, and then maybe store it here in a local variable, right, and then render it. Right. So let's do that. Okay. So let's see. Yeah. So what we're going to be able to do is locally here have a state variable, right, that we can use maybe with use state. Oops. State, right? That can allow us to declare an empty array, right, of courses, and go and fetch the data from this URL from a remote resource, and then populate my courses array here, right, and then render it. That's what I want to do. That's the purpose here. Here, maybe I'll declare this as any. There we go. So right now it's empty. I don't have any courses because my local array is empty. I need to populate it with the data that lives in the server. Everybody good? All right. All right, so how do we do that? All right, so to do this, we're going to need the help of a library called Axios, right? So we'll do npm install Axios, right? And this library is going to allow us to programmatically do this request, right? Okay. And we can see the communication is going to establish an HTTP request, localhost 4000 is going to generate this request, and the server is going to respond, and we need to catch that response from the server, right, and populate our courses, right? And we can see the communication between these two processes from the inspector, right? So from the inspector, if we look at the network tab, we will be able to see that communication, right? So let's do that. All right, so to do this, we're going to do the following. We're going to say, I'm going to import the Axios library, right? And then we're going to do Axios dot get courses, and just that, only that, right? And as you'll see, notice that the library indeed generated the request. See that? Localhost 4000 API courses, it went out, right? It did go out to the server, but the server didn't like the request, right? It's complaining, right? It's responding with a course policy violation, right? And it's violating, right, one of the rules that browsers impose on JavaScript security policies, right, of JavaScript that are running inside of a server, right? They are they can't access the file system. And if they're going to do a network connection, they can only talk to the server they were downloaded from, right? And this is telling us that the JavaScript file that is trying to establish this communication was downloaded from localhost 3000, and that's true, right? That's where our React.js application is running, right? On that port, and it's saying that it's trying to communicate with somebody who's running at port 4000. Okay, so even if you're in the same IP address, and if it's a different port, right, it's a no-no. You can't do that, right? It's considered to be a cross-origin request, right? CORS stands for cross-origin resource sharing. Okay, and the policy is that no, you have to be in the same IP address, the same port, right? It is a security violation to try to go across domains. Okay, so and again, this was done early when JavaScript came out, in the 90s, right? Early 90s, that folk, were, kind of like pushing back on JavaScript. People were disabling JavaScript, disabling cookies, right? There was a lot of paranoia on what these executables would be able to do once they were downloaded and running inside your browser. So browsers and developers, created these policies, right, to make people feel more safe, right? That they could use this without any security risk. So anyway, so even though those policies were put in place in the early 90s, the developers ran up against these limitations very early on. They were trying to build things, and it was very restrictive, right? One of the solutions was that the JavaScript would, instead of talking directly to a URL to some other server, they would instead talk to their own server, right? And then that server would then just echo those requests out, right? And then they would come back and then respond back to the JavaScript, right? Right. And this was the proxy server architecture, right? You had a proxy, right, running in your server that just was basically just echoing your request, because you could not, right? You could just talk to your server, and then your server would then echo your request out, because they had no limitation. Only in the browser was the limitation. Yes. So that was one solution. There were other hacks, using JSON-P and other ways to get around this security issue. But eventually, about 10 years ago, 15 years ago, they came up with an official standard solution to this problem, right? Of instead of just blatantly not allowing this, right, not allowing JavaScript to just talk to anyone, instead, you could establish a policy where you could ask for permission. You say, do you allow me to make these communications? If you allow me, I will go out and talk to these servers, right? I'm not just going to do it because I want to. It's because you're going to give me permissions to do this, right? So CORS allows us to establish the policy, allows us to say, allows the browser to ask for permission. It goes out to that server and says, hey, server, there's this JavaScript that was downloaded from this other domain that wants to talk to you. Is it okay? And then the server can respond, yes, no, right? Or what are the limits? Okay. It can blacklist, or it can, whitelist certain things that can or not allowed to do. Yes, right? So let's do that. Let's go out to the server, and we can do this because we own both ends, right? We own the front end, and we own the server, right? And we know that it's secure for us to talk to one another, right? We're not just willy-nilly talking to anyone, right? We're talking to our own server. It's our own application. It's split up into multiple servers, right? But we want to establish the communication to be secure. Yes? All right. So let's go back to the server. And here in the server, what we're going to do is that we're going to install a library that is going to allow us to configure the CORS policy, right? We're going to do npm install CORS, right? There it is. So we install CORS. And now we're going to import CORS like this, and then we're going to configure CORS, right, to establish the CORS policy, right? And the simplest of which is to just use app.use course, right? So this has to be done right after, or the very first thing that you do, right after instantiating the Express instance when you get app. Okay, like for instance, you can't just do it maybe here in the middle like that, right? If you do that, then all the ones that come after will be able to talk to the JavaScript user interface, but anyone who comes before will not. Okay, so it has to be done before any, before any communication gets started. Everybody good? Right. Also, app.use means, app.use means, if we look at the routes, here we have app.get, yes? And app.get says, if the server receives a request of type get, right, and the URL looks like that, then I will execute this function. Yes, that's what that means. App.use is more general. It says, I don't care if it's a get or a post or delete, right? For all requests of any type, and also I don't care what the URL looks like. I don't care what the path looks like, meaning basically for any request or for all requests, right? For any request that's coming in, I want this to happen. Yes? Whatever course says, right? And what course is going to do, right? It's going to respond to the browser what the policy is, right? What the policy is. And the way we configure the policy is with an object in here. We can configure the policy providing an object in there. But for now, we're going to leave it empty. What this does is that we have no policy, right? We're saying we are allowing everything. Anybody can talk to us, right? We have no prejudice for anyone to talk to us, okay? Right? So let's do that. The server is running. Let's go back here and let's try this again. Okay, so this time around, notice that it did not complain about course, right? We did not fail the course. And in the network, we see that indeed the course did go out. Notice it's not red. It's not complaining anymore. And we can see that the server did respond with data, right? The server did respond with data, but we're not doing anything with the data, right? It just came. It came back as a response. We never caught it, right? What we want to be able to do is to grab that data, right, and populate the courses. Yes? So let's do that. Let's do that. Okay. So ideally, it would look something like this. Ideally, it would look something like, cons, and then you grab some variable, right, and you'd be able to do something like, set course q. Ideally, it would be something like that, right? Unfortunately, it's not. Okay. So the communication. Notice that I'm not saving. I'm not saving. If I save, I'll probably get into an infinite loop, right? And so I'm not going to save. Actually, I'm going to comment that out. I'm going to be careful there. So what's happening here is that this communication between the browser and the server, the communication is asynchronous, right? And by asynchronous, it means that these function calls, right, don't block, meaning the function call is invoked and we don't wait for the function to return. Okay, meaning that typically when we make a function call, right, typically we wait for the right-hand side to complete. And once the right-hand side returns, right, whatever returns, we can assign it to the left-hand side. Yes, that's a typical von Neumann, right, sequential synchronous computation that we've been using for most of our lives. Yes, most programs are like that, right? From everything executes from top to bottom, from left to right, right, sequentially. Yes, here, no. This request goes out, right, and we don't wait for the response, right? And the reason is that the server could be down, right? It could be taking too long, right? There could be network issues, right? And so we don't want to be caught here waiting indefinitely, right? If there's a network issue, okay? Because if we get stuck, our entire user interface becomes blocked, right? It cannot interact. We're not going to be able to click anymore, right? We can't play those cat videos anymore, right? So it's blocked, right? We can't do anything, right? So instead, this is asynchronous. What's happening here is that this API is asking the browser. The browser can have any number of requests, right? Can have any number of threads. It says, hey, browser, go and fetch data from this URL. Use the URL, go and fetch data, right? I'm going to go do something else, right? And once you're done, let me know. Call me back. I'm going to leave a callback function for you, right? I'm going to leave a callback function, right? So what this actually comes back as a promise. This comes back as a promise, right? An object that is going to allow us to set a callback function here. We can put here a callback, right? Where the actual response at some point in the future will come back and we can display the response so we can see what it is. Okay? So this is basically the browser responds with an object that allows us to register for a callback, right? That at some point in the future, when the browser receives a response from the server, right, it will call our function and it will just pass us whatever the server came back with. Yes, the response, right? And we use this .then. .then allows us to register for that callback. Everybody good? Right. Okay, so let's look at the response. Let's refresh. Let's go to console. Console log. Requests, courses, API courses, promise.then, console response. Okay, there it is. I had not saved. There it is. This is what the server responds with, right? It's a whole bunch of meta information, right? Most of it I don't care about, right? It's saying that the request was successful. Status 200 means that the request was successful. A whole bunch of headers, including cookies and other data, but the actual data is right here, right, in the data. So the response.data contains the actual data, right? There it is, right? And again, we would be tempted to do the following, right? Because the actual data, it's response.data, right? Right. Let's save. There it is, right? We're just printing out the data, just the data, right? And again, we would be tempted to do the following, to do set courses response.data. I'm not going to save, and that's going to cause me to go into an infinite loop, right? And the infinite loop will generate, right, recursively requests out to the server, right? Because when I set the data, it's going to cause for the component to re-render, right? And if the component re-renders, is going to again generate a new request, which is going to set the data, is going to re-render, which is going to cause a new request. So I'm going to get into an infinite loop, right, of infinitely, generating, requests to the courses. Yes, right. And I know some of you will do this, and now if you do it locally on your machine, it's okay. It's your server. Your server will eventually crash. Okay, but if you deploy this to Netlify, and you start hitting your server that's running on AWS or Render.js or Heroku, right? Heroku might not like this, right? That you're trying to hit their server continuously. They're gonna consider you as a denial of service attack, right? That you're trying to crash their server, right? And they might put your account on probation. So careful. Always look in the network that you don't have an infinite set of requests going out to the server, right? Test it locally, make sure that's not happening, and then move it over to your Netlify. Make sense? Okay. So we can't do that. We can't just do this, right? We can't just do that. Not yet, anyway. We want this to happen only once, only once, right? When this loads, I want to go out to the server, set the state, and then never again. Okay, so how do we do that? So to do this, we're going to wrap this in a function that we can call, and we'll call it, const, fetch all courses or something. Right? It's a function that we can call like that, right? And again, we're not going to call it. If I call this, I'm going to get an infinite loop. Instead, we're going to use a hook that is specifically for this case, for this use case. The use effect hooks allows us to behave like a constructor. Okay, like a constructor, it does some setup, it does some initialization. It allows us to initialize the state of the component, and then that's it. Right? If the state changes, it's because the use effect initialized it. It's a constructor. It's only for initialization purposes, and then it's not going to re-render automatically. Right? So let's do that. We're going to do use effect. Use effect takes as argument a function. That function is going to be invoked once, right? And then never again, unless variables in here that are declared in this array, if they change. If they change, then yes, I will go and get some, I'm going to rerun this, right? But since we're not going to change anything, I'm going to leave it empty, meaning that this has the effect of only running once, okay? Yes. Yeah, because this change of state, when the state changes, it forces a re-rendering of the component. If what? Right. Yeah. No. No. Oh, right. Well, the way we have it here is only once. The other way was going to hit it many times, even if it would respond. Right. We keep hitting it. Right. Even if it was responded, it would hit it again, and then it responded, and then it would hit it again, infinitely. Right. If we just had this, right, without the use effect, yeah, we have an infinite loop here. See that? See that? We don't want this. I'm just going to have to kill the server, the browser. That's the only way to recover. I need to kill the browser. Right. So with use effect, it's going to do it only once. Only once. It'll call it. The state will change, right, and then never again. Okay. So wait a minute. Let me. I need to do this again. Localhost 3000. Canvas. And here. Okay, so yeah, so what's happening here? We have the inspect network, refresh. So there's our it's calling the function here, right? And it's doing the promise. Let's go to the dashboard. There we go. There we have it, right? Here's the data. Here's the data. This data is coming from the server, right? We're catching it and we're setting the state, right? Of all our 21 courses now. There's 21 courses, right? They're coming all at once. Everybody good? Okay. And if I refresh, right, I'll just go fetch it again and reinitialize the user interface. Everybody good? So basically, what we've done is we've moved the state, right, the data from the front end. We moved it over to the server. Yes. Yeah, that's for debugging purposes. It calls it twice. We could turn that off. It's a configuration flag. Yeah. Yep. Yeah, we'll see that, how to turn that off. Okay. All right. Okay, so now this syntax that we're using here of promises, okay, it's a little awkward to work with, right? And it's awkward because of the nature of the asynchronicity, right? And this syntax is literally what the browser knows how to do, right? This is literally what it's executing, but ES6 introduced a syntax, right, that allows us to rewrite this so that it's much easier to read, much easier to what we would expect this to how to behave, right? This is it allows us to rewrite this as if this were synchronous, right? As if it were blocking, waiting, okay, giving us the response, and then we can parse it out of there, right? So let's rewrite this so it's a little bit easier to read, right? So what we would love to do is for this to be rewritten as follows, right? I don't want to throw this away. I want to leave it to you for you here. So I'm just going to comment this out. We have the request goes out, and what comes back from the server is a response, right? Response. And we would like to be able to say that the courses, or we would like to be able to set the courses, set courses as the response.data, like that, right? That's what we want to do, right? This would be the ideal syntax. Certainly would be much easier to read, right? But obviously this is not what's really happening down underneath, right? So what ES6 has done for us is that it has added 2 keywords, right, that allows us to behave the way we would be expecting this, right? The keywords are async. If we know that the underlying communication is asynchronous, we can tag our function, we can tag it as async, right? And the actual invocation that is asynchronous, we can prepend it with await, right? And then it behaves the way we would expect, right? What's really happening here is that underneath, right, browsers don't understand the keyword async and await, right? What happens? What they do understand is the promises and the .thens, right? That's what the browsers understand, right? So when this gets transpiled, from this high-level ES6 syntax, it gets converted down to this syntax, right, for us automatically, right? But allowing us to abstract, right, think about this sequentially. It allows us to think about it sequentially, but really what's happening is asynchronous. Everybody good? Right. So certainly this is much easier to read, right? Much makes more sense. Okay. All right. And it works. There we go. Right. It works perfectly. The other issue here is that just like we introduced Redux, right, with the intent that it was a good practice, right, that components should not have to deal with their own state management, right? That it was a best practice to split that into 2 separate concerns, right? That division of concerns, right, was a good thing. It was a good software engineering principle, right? So we broke it out into 2 concerns. The data, the state management, we put it in Redux, right? And then now we have the user interface component only render, just deal with the front end only and the user interaction. Okay, but the data management, we moved it over to a separate file we call the reducer. Yes, right. Well, here too, this is another best practice: is that components, again, they should only be responsible for rendering, not interacting with the server. Right. This here of interaction with the server should not be the responsibility of the front end, right? Of a user interface component, right? So let's break this out into a separate file, right? And have it like a reusable component that anybody can talk to the server. Right now, only this component can talk to the server, right? Because the logic is only in this one component. Yes? So let's put it in a separate file so that it can be reused by anyone who wants to talk to the server. So for that, we're going to create another file. And I'm going to call it client, right? In the sense that this is the client side that's going to talk to a server side, right? And so I'm going to move this code. I'm going to copy it here. I'm going to move it over here, right? I'm going to export this, right? And I need Axios, so it's import Axios, right? I don't have set course. But I can just return this. I can just return response.data, right? I return response.data. Now I can come back here, and what I can do is I can say I'm going to import that client. I'll import all the functions from that client. I'm going to call it locally as my course client, from courses client. There we go. Right, and in here, I'm going to const courses await course client, and I think I called it fetch all courses, right? And then I'll just set the courses that comes back from the server. Yes, right? So now it's not the responsibility of the user interface to go fetch this, right? That's separate. I just know, I have no idea how it's retrieving this, right? It's not on my business, right? How it's retrieving this, right? It could have been just as well as a local file, right? And it's abstracted out. Everybody good? Okay. All right. Awesome. Okay. Yeah. So that worked. Let's do it again. That was fun. Let's do it again. In particular, if I click on a course, right, and I navigate here, right, this page also is rendering a course object. From where? From the courses.json file, right? Okay. So let's revisit that. Let's re-implement this. Okay, let's re-implement this. This is in the courses page. Let's say courses here. I believe it's here. So this is rendering this. Right? So let's re-implement this. Okay, this name for the courses name is because we are retrieving from the array of courses. We're using the ID, the course ID that is in the URL here, this URL, to find it in the local courses JSON array. Yes? But we don't want that, right? Instead, we're going to break it, and we're going to instead fetch that from the server, right? So let's do that. So from the server, I want to be able to retrieve individual courses. And in my courses routes, I only implemented retrieving all courses. I never implemented retrieve a course by its ID, right? So let's implement this, right? So again, following RESTful API conventions, the URL will look like this, right? Let's start with API, the noun, plural noun, and then encode the primary key of the specific item that we want, and call the retrieve course by ID. So the implementation of this is that we would parse out the parameter, right? And look for that parameter in our local array in the db.courses, so that if the ID matches, then we respond with that course. If it doesn't match, and if we couldn't find the course because you gave us a bogus ID, we'll respond with a 404, right? Did not find it, could not find the course for that particular ID, right? And we'll say, course ID, blah, 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 not found, right? So we can try it out. We can try it out here. We say courses, and we'll use RS102. right? It comes back with, it thinks it's an integer. Thinks it's an integer. It's not an integer. Oh, it was parsing it out as an integer. No, we don't want that. It's not an integer. Try it again. There we go. We can retrieve that particular course by its primary key. And if we give it a bogus ID, it'll come back with a 404 saying, that ID does not exist. Everybody good? Right. So now that we have that, we can go back to our front end, right? And our client is going to have to do the same thing that it did for fetching all courses, right? It needs to be able to retrieve one course, an individual course. Oftentimes these names, what I like to do is use these names as being exactly the same names on both ends, right? Because this is the server side, right, that is responding, but the other one is on the client side, right? And I often like to use the same name on both sides so I can keep it straight in my head. And so I'm going to rename this the same thing that I use here from the client, just so that I can keep it straight in my head. So I'll paste there. I'll paste that here. Okay. And I guess I'll rename this too. I'll call this, find course by ID. Find course by ID, like that. Okay. So in the user interface in the client, I'm going to use the same name. So here's going to have export fetch course by ID, or find course by ID. It's going to do the query. Notice it's receiving the ID as a string, as an input. I am encoding it at the end of the URL. See that? And then I'm responding with the data. Okay. Why are you complaining? What's going on? Oh, right, because we broke the array, right? We removed the array. Okay, so now that we have this in the client, right, obviously we're going to have to implement all the other stuff, right? We're going to have to implement, everything that's here, all these, right, also need to be here, right? These are all going to be async functions, right? Oops, with no request or response. So all these functions are going to be here at some point, right? These are all going to be async. So for every single endpoint on the server, yes, there has to be an equivalent or corresponding client, right, on the front end. Yes, right. So this is we're here on the end of the front end that's sending all these requests over to the server, and then the server responding with all this data, and we're catching it here, where we're parsing it out, we're unwrapping the data, right, and then we're returning it to our front end. Yes, right. Okay, so let's use this. We can use this to re-implement here in the courses. We can re-implement this by, comment that out. This would be a state variable, course and set course with a use state, right? With a like this, with maybe a name, with an empty array, with an empty object. Okay. We'll bring in the client. So import start as course client, the client. It will create the function that is going to use that client to go fetch the course and set the local course in the local state variable. And we'll use use effect to call that fetch course, right, only at load time. And we'll bring in our use state effect. Okay. Here's fetch course. Oh wait, no, fetch course by ID, I think it's called, right? By ID. Oops. Fetch course. Oh, sorry. Find course. I knew that. I was just checking to see if you were paying attention. So if we go to, notice it's complaining that course ID could be null, right? That I didn't type the actual ID at the end. So we could go here and declare this as maybe as, there we go. See that? It's fetching the course from the server. We could see in the network, right, that it's fetching that particular course, RS101, right? And we are just printing out the of the information for that course with a primary key. Everybody good? Yeah. So now if I say RS102, notice that RS103, it's not changing. It's not causing another request. See that? That request is now stale. It went out, and it's never again going out to go fetch it again, right? But ideally, if I would change this on the URL, I would like this for this to change, right? To do the query again and fetch the data. Okay, it actually does work if I go to dashboard, right, and I go to a separate one like aerodynamics. There it is. See that? It is fetching, right? And if I go back and I click on another one, it does fetch. Yes, but it's because it's re-rendering the entire component, right? It's the first load. It's like the first construct that's being reinstantiated. But notice that it doesn't do it. Once it's done rendering, it doesn't pay attention to the changes in the parameters. See that? But we would want that to happen. We would want it to keep an eye on that change, right? And so the way we could do that is we can say that this course ID is changing, right? And if it changes, we can establish it. We can add it here as a dependency, right? As a dependency here, and say, okay, well, if that variable changes, I would want you to reconstruct, right, and redo this again, right, and rerun the function in here, right, so that it can re-render with the new changes. And now this should work as expected, right? Now we should be able to say RS102, RS101, there it is, see it changed. RS103, it's changing. See that? It is re-invoking the request out to the server, fetching new data, and re-updating. Make sense? Okay, very good. This will be very, very important later on, in the project, right? When you have to interact with a third-party API, right? And you're doing searches and whatnot, right? And you're navigating forward and then coming back in the history, and the history has in the URL, all these requests, all these query that we want to re-render the components, right, with data that is encoded in the URL. We'll come back to that a little later in the course. Okay. All right, everybody good? Right. Okay, so what about right now? We have been discussing being able to retrieve data. What about creating new data? What about creating new data? Right, so to create data, right, if you want to create courses or update courses, delete courses, the RESTful API, if it's RESTful, right, if you're creating new data, right, the convention says is that you would use a app.post. And there it is. My AI knows about RESTful API conventions, right? It would be, the URL would be to the courses, right? The plural, no ID. Right? And this is interpreted as being, I'm going to send you a new piece of data, and you're going to add it to the current collection or array or set, right, of objects that you already have as a brand new object. I'm going to post a new object. Okay, I'm going to make a new post. So, and the convention also says that the data would be encoded as an attachment in the body of the request. Okay. So here, the request is going to have a body. Right? We're going to parse it out. There it is. In the body, we're going to have the course. We're going to extract it from the body of the request, and we're going to push it in an array of courses. And we're going to respond with the brand new course. Now, typically, this object, instead of being pushed to an array, in reality, typically it would be inserted inside of a database, right? We'll do that next week. Right? Now, one of the things that happens when you insert a record in a database, it's given a primary key, yes, by the database. Right? So we're going to fake that. We're going to fake that by taking the data that comes from the user interface, which typically doesn't have a primary key. Right? We're going to take that, we're going to spread that over, right? And we're going to create our own primary key. And we're going to convert that into string. Convert that into a string. So it's like a timestamp, right? And it's a string. All right. And now the body might contain the name of the course, right, which I've typed at the user interface, the start date, the end date, how many seats, things like that, right? And that would all come from the user interface. I'm just adding the primary key here. And then here I would insert it in the database, or right now we're just pushing it to the array. And typically what I would respond with a brand new course. That is the proper thing to do. But because I'm running out of time, I'm going to respond with all the courses. With all the courses, including the one that we've just added, right, for convenience. Typically, you would not do this. Typically, you only respond with the single course you just added, right? But for convenience, this is much more convenient. Okay, so let's try this out. Now, the thing about this is that you can't try it out directly on the URL, right? You can't directly type in here and generate a post, unfortunately. You can only generate gets from here, from the URL. Okay? You can only generate posts from the front end, from REST, from our React application. So let's do that. Let's add to our component, to our dashboard component. Our dashboard component, let's create a little state variable that we can edit a course, right? And let's create a little user interface here where we have we'll have an input field with a placeholder, and this is the course name that we can edit, right? So we'll have the value to be the course.name, and we can do an on change, excuse me. And let's do set course with a with the old course plus the name. It will be the e.target.value. Okay. So back in the dashboard, I can now type in the name of a new course that I want to send over to the server. Yes, right. And so I want to be able to then post this maybe as a button. We can add the course or save or add course as a button. There it is, right? And we're going to handle that locally in a const add course like that, right? And we're going to call this from the button, on click add course. Yes. And when we click on it, what does have to happen? We want to be able to send a post like that, just like that. We're going to be able to send a post, and we're going to be able to grab the body with the new object that we're sending over. So for that, let's go into the client, and let's create this course. We're going to receive as an argument here the course object of type any, right? And we're going to post, right? We're going to post to that URL, right? That is the correct URL, right? Notice that it has a comma course. See that? Second argument to the post is the object that we want to send in the body, encoded in the body as JSON, right? And the response, in our case, is going to be all the courses, right, including the brand new course that we just added, right? And we need to export this. Export. So now from the client, from the dashboard, we can call, right? We can say the new course. We're going to call the course client create course here, create course, like that. It's going to come back with all the courses, right? And we're just going to update all the courses here. Yes, everybody good? Right. All right, let's try it out. Let's try it. Let's see if this blows up. Why is this? Huh? What the? Huh? What the? Okay. Anyway, so let's create a couple of courses. So let's create CS 5610-07 add course. Okay, it didn't blow up. Did something happen? Oh, okay. So looks like this is my new course. My new course. It looks like it only took the ID. All right, so it ignored my name. We should be able to see the post going out. We should be able to see the post. If you see network, right, and we say course 101, add course, there's my post. Actually, no, before it makes the post, notice what's happening, right? It's asking for permission. It's going out to the server asking for permission. It's sending a localhost 4000 API courses options. See that? It's asking the server, what are my options? Okay, and the server responding that these are the actions that are allowed. You can post, you can put, you can get, you can delete. Basically, you can do whatever you want, right? And once the browser receives all these methods that are allowed, it actually sends the post. Right, then it sends the post. If it gets, and that's our course library talking, right? Saying, yep, you can send everything, right? And we do, and we can see that in the payload, this is what we're sending. We're sending just the name, okay? But apparently, there's the first one that we sent. Here's the second one, okay? And they're there. If I refresh, notice that indeed they are stored in there. And if I go here and I ask for the courses, at the bottom, we can see the two courses that we have added. So it's ignoring the object that we're sending in. And the reason is that by default, the server, Node.js, doesn't know what to do with that body that is coming in, right? It doesn't know how to parse it, how to interpret it, right? And the reason is that we can send anything in the body, right? We happen to be sending JSON, right? It's a string. It doesn't even know what type of string is, right? We could send a PDF document. We can send an image, right? We can send a movie. We can send anything. We can attach anything to the body, right? It happens to be JSON. So we can configure our app, right, to try and parse this as JSON that we're sending. We're trying to convert it into a JSON. So, and there it is. It's as trivial as saying, express.json, right? It's a function that tries to parse the body as JSON, right? For any request, get, post, put, delete, all of them, right? If it finds it that it can't parse it as JSON, it'll make it available in the body, right? So now it should work. Let's try it out. So let's go back here. Let's refresh. Now my old objects are gone because the server restarted, right? So my all the things that I've created are gone. So let's try it again. So CS1234, add course. Let's see. There it is. CS1234, right? Or CS2345, add course. There they are, right? And if I go back here and I refresh, right, I should be at the bottom. There they are, right? So they are being added to the array on the server. If I refresh, unlike the user interface solution, the server solution is permanent. As long as the server is running, right, all the data is being maintained in the memory of the server, right, and it remembers until it reboots. Everybody good? Next week, when we start in the database, it can even survive a server reboot, right, which it can't right now. Okay. Everybody good? Okay, so we can create. What about deletion? Delete a course. All right, so let's delete a course. So to delete a course, the convention, right? The convention is to use app.put for updates, right? And app.delete for removals, right? In both cases, we would encode at the end of the URL the ID of the course that we are either updating or the course that we are deleting. Yes, right? And so let's do delete. So delete In both cases, we would retrieve the ID of the course, right, from the path parameter, the ID, there it is, so there it is. We would find to check to see if the course is indeed in there, right? If it's not there, if it is there, we're going to splice it out from the array. In the database, we would send a delete message to the SQL statement, right, or MongoDB, and then respond with all the remaining courses. If we did not find the course that you asked us to delete, we'll respond with the 404. That course you're trying to remove, it's not there. Okay? Update, it would be something similar. It would be, again, the ID. We would find it. We would replace the old course with whatever you sent in the body. So the body will have different properties that we're editing. Maybe we're changing the start date, the end date, right, or the name of the course, right? And it would override whatever old instance of the course, right? And we would put it back into the instance, and then respond with all the courses. So for delete, let's implement delete here. So just like we had a delete on the front end and the back end, we'll need a delete on the back end and the front end here. We'll receive the course ID as an argument, as a string, right? And we're going to use Axios to send a delete to /courses/the ID, perfect, right? And then the response with all the courses that survived, right? We're going to export this, right? And then in the dashboard, we can put a delete button in all our courses. Maybe have a button here, button, and then have this danger. This will be delete. Right, there it is. And maybe put it, we're going to float it to the end, right? And if we click on it, we're going to handle the event handler here like delete course, right? And so in our delete button, we're going to do on click, invoke our delete course, right? And pass the course.id, right? And invoke the course.client delete course, right? And then set the remaining courses, right? So let's see if that works. Let's see if this blows up. So we can go up, and can we delete? There we go. We can delete courses, right? Including courses that we create ourselves. And so if we create CS5431 and CS, right? We can delete our own courses, right? Or existing courses. And if we refresh, we'll see that the changes are permanent. Everybody good? All right, awesome. Let's take a quick break, and when we come back, we'll talk about maintaining state session, okay, on the server. All right, let's continue. So one of the questions on the chat was, what if we want to do kind of the same thing, the request, but without using the Axios library? And yes, we could. There is a native solution without the Axios library. What is up with my browser? So instead of using the Axios library, there is the fetch library, right? That so instead of using Axios.delete, we could use fetch. Fetch is a native JavaScript function that is available. Although it's not as secure, it's not as thorough as the Axios library. And so folks tend to prefer using the Axios library instead of the of this low-level fetch library, right? But it does the same thing. Someone mumbling? Time? Thank you. Okay, so let's continue. So one thing that I did want to point out is that right now, right, all these APIs are accessing just a single data set, right? Only courses, right? But oftentimes, the data set contains pieces of information that are somehow related to one another, right? Not just these flat maps. Yes, typically we have students that are enrolled in a particular section, right? And you have courses that have multiple sections. So you have a lot of one-to-manys or many-to-many relationships, right? With one course having many sections, and then one section having many students enrolled in those sections. Yes. And then one student enrolled in many different sections for different courses. So oftentimes you have these relationships between objects. Yes. So to illustrate that, let's take a look at the implementation for, say, modules. Right? Modules are, contained within courses. Right? A course has many modules. Correct. And indeed, the data type, the array for modules, indeed has a field called course. To what course do I belong to? Yes. And it has the primary key of the course that it belongs to. Right. So we have this course that belongs to this module that belongs to RS1, and here's another module that belongs to the same course, and yet another module, and then here's a module that belongs to a different course. Yes. Right. So we would like to be able to, provide access to this data, but this data, typically you would not access the entire set of modules. Indeed, you would only access a subset of the modules, right? Within the context of the specific course that you're in, right? So if we're building the routes for this, let's say we're creating for the modules, and we're creating the routes for this, right? Yeah. You would have export default module routes, right? You have a app, and this is a function, right? So you have the CRUD operations, right? And so one of the operations would be fetch all modules. Although, is that realistic? Did we ever have the use case where we want to retrieve all the modules, where where the modules go across multiple courses? Would we ever consume all the courses? All the modules? Probably not. Right? It would only make sense that I would consume only the modules within a particular course. Yes. Well, unless I'm a system administrator, right? I want to see all the modules across all courses because I am looking for inappropriate content or something, right? I don't really care what course it's in, right? I just want to make sure that there's no inappropriate content in any of the modules across all my courses. Then yeah, maybe that might be a use case, right? Where I want to consume or view all the module content across all courses. Yes. But even then, probably that's a kind of like an edge case. How about retrieving a module by their primary key? Yeah, maybe, right? Maybe I do want to retrieve a specific module. Maybe I want to be able to go into that module, edit it, right, and then save it back. So yeah, that makes sense, right? So I might retrieve the primary key of that module and then find that module. Otherwise, I would say I couldn't find it. But more commonly, I would like to find module for a course, right? Where we would, send a course ID embedded in the URL, right? And then take all the modules and filter. Only keep the modules for which the course matches the ID of the course that I provide in the parameters. And if there are any modules, I'll respond with an array. Otherwise, I'll say that course doesn't have any modules. Right? So that's a more common operation. I can create modules, I can delete, update modules, or delete a module. Okay? So those are common operations. So let's look at this one. Let's implement just this one at least. Right? So what would be the URL for this, right? Well, the RESTful APIs, again, if you are retrieving all the modules, again, right, this would be the appropriate URL, right? It's a get operation. We're reading the data, right? And then we're saying /API/modules, meaning I want all the modules, yes? Or if you want an individual module, I would encode the ID as part of the URL, perfect. Now, but if I'm asking for the modules that are inside of a course, the proper way to encode it is as our AI suggests here, right? You start off with the path from a higher level context, right, into a narrower level context. Yes, right? Just like a file system, right? You start at the root that contains all the content, yes, and then you CD into a particular subset or subdirectory, yes, and the path is read from left to right, meaning that left-hand side folders are a higher level hierarchy than the folders on the right-hand side of a path. Yes? So same thing here. Right? You start from the root, and then these paths are the equivalent of branches as you navigate through a hierarchical structure. Make sense? Right? Where you start at a higher level course, right, and then you go into a narrower context of a specific module. Make sense? Right? So yeah, so this is the proper structure of this of the path, right? And then we find the modules for a course, right? So anyway, so let's try to implement some of this. So back in app.js, right, would be import the modules routes, right, and provide the app for this. And to try it out, we should be able to fetch all the modules, and that didn't work. Wait, what happened? DB modules. Oh, I never imported the database. So import the database, go up to database/index.js. There we go. So this should work now. There we go. We got all the courses, all the modules. And if I give you, I can retrieve a specific module, right? Or I can ask for the modules for a given course, RS 101. So those are the modules for that particular course. Make sense? Right? And it's not all of them, only those three. Right? Okay, so let's do it. But on the client side, I want to go and fetch this, right? If I navigate to a specific course, or if I navigate to RS 101, I want to see the modules for RS 101. But if I navigate to aerodynamics, I would like to see the modules for RS 102. Make sense? Right. So let's implement that. And let's see. Now, typically, we would implement the client. Right. This is a client for the courses. If we're doing modules, I guess we never implemented the modules. So I'm going to create under courses. I think the modules went under the courses, if I remember correctly. So I'm going to do modules, and I'm going to create a client under here, which is going to be the responsible for talking to the client that we just built, right? We're going to import Axios, right? And in here, we want to implement all the modules, or find a particular module by their ID, right? But the one we really want to care about implement now is export const, find modules by course ID or for course, right? Where we're going to provide the course ID, and we're going to do a notice that it already knows that it's configured and the structure is of a RESTful API URL. Perfect. And so that would be the modules for that particular course. Perfect. And export it. So let's render it. I guess we used to have a module list here, but we never implemented it. So I'm just going to implement it inside of the courses. So in the courses, I'm going to retrieve the client for the modules. So import the module client, and it's from modules clients. Very good. And I'm just going to fetch the modules for the course. So I'm going to say I'm going to need an array for that, a state variable for that. So you're going to have a const modules is going to be an empty array. I'm going to fetch that. So const fetch the modules, passing the ID. I think modules. I think no, the name is for course. Is it? I think. I forget. For course. Find modules. Oh, find modules for course. There we go. I'm going to set the modules. We're going to invoke it also at runtime here. And then we're going to render down below the modules. So modules, pre modules. There we go. There's our modules. And these modules are for that particular course, right? If I go to a different course, like aerodynamics, these are the modules for aerodynamics, right? Fundamentals aerodynamics, subsonic superflow, blah, 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 aerodynamic heating, right? And if I go to spacecraft design, I'll have the modules for spacecraft design, orbital mechanics, and spacecraft systems. Yes? Obviously, we would have to render this as a list or whatever, however you're rendering it, or copy it over into the reducer, right? And then the reducer would have its own state variables. Right now, here we're using just plain old use state. Yes, right. But if you're using reducers, you would call the set modules in your reducer or whatever, right? And so anyway, the assignment walks you through what we've discussed today, right? Creating the databases, working with the routes for the courses, and integrating it with the user interface, as well as modules, right? And then deploying this to a remote server, either on AWS, render.com, right? Or Heroku, however you want to deploy this, okay? I think Heroku has a free tier for students, but you have to apply with the student email, right? And they give you a certain number of hours or points that you can spend for your application. Render.com, I believe, is entirely free, but it does have its limitations. For instance, if you haven't used the server for 20, 30 minutes, it puts the server to sleep, right? So that if the first hit, it might take a few seconds for the server to wake up, right, and start responding, right? But that's free. So anyway, so there's several options that you might want to consider.